The cosmic record has been broken, and it has astronomers scratching their heads. Researchers have discovered the most distant oxygen ever found in our universe, in a galaxy so far away that its light took 13.5 billion years to reach us. This galaxy is just a baby, and it was one of the first to form in our universe. What's puzzling about the new results is that this baby is, chemically speaking, a lot more mature than we would have expected. This galaxy, JADES GS Z14-0, let's call it JADES for short, was first discovered with the JWST and pegged to be the most distant galaxy ever observed. Since light travels at a finite speed, this also means that we're looking back further than ever before. So studying this galaxy can give us vital clues about the state and evolution of the very early universe, when the foundations were set for everything to come. So when this detection was announced, astronomers were super excited and raced to follow it up with ALMA, in which ESO is a partner. ALMA ideally complements the JWST because it observes a different type of light. With ALMA, we can observe in the millimeter and submillimeter regime, while the JWST looks at infrared light. We can then take the two different types of observations and piece them together like a puzzle to really find out what's going on. In the case of JADES, this collaboration between telescopes worked extremely well. JWST gave us infrared imaging, which detects the light coming from the stars in the galaxy, and allowed us to measure its distance approximately. ALMA detected oxygen, which originates in the warm gas around the stars, and allowed us not only to pinpoint the distance much more accurately, but also to better understand the chemistry. Turns out, this galaxy, JADES, is a lot more chemically mature than we expected. The thing is that initially, our universe consisted essentially of hydrogen and helium, with only small traces of other elements. Heavier elements, which we astronomers just call metals, are formed only by the life and death of stars. So, the level of metallicity that we measure is a good indicator of how many generations of stars have come before. In a very early galaxy, such as JADES, we expect most of the heavy elements to have been formed in supernova explosions. So the fact that we measure a higher metallicity than expected means that more stars have lived and died with a bang than we thought possible at this early stage of the universe. Another thing that was surprising was how massive and luminous this galaxy, JADES, is. According to state-of-the-art models, the very first small galaxies started forming about 150 million years after the Big Bang, but they had masses of only a few thousand suns. It was only after about 300 to 400 million years that these galaxies started merging, forming more and more massive galaxies. But after only 300 million years, JADES already had a mass of a staggering 400 million suns. This is simply too much, too fast. This indicates that the build-up of galaxies in the early universe occurred much more rapidly than we thought possible. Another thing the ALMA data allowed us to do was to pinpoint the distance to JADES very accurately. Us astronomers like to talk about the distance of faraway objects in terms of redshift, because if we used kilometers or even light years, the numbers would just become mind-bogglingly huge. The concept of redshift is based on the expansion of the universe and the fact that the further away an object is from us, the faster it moves away. This causes the light emitted to be redshifted. Imagine I am standing here and I'm observing a galaxy that is emitting light with a given wavelength here. If this galaxy starts moving away from me, the light wave will appear to be stretched. So I'm going to observe a longer wavelength than what was originally emitted. And this effect is more pronounced the faster the galaxy is moving away from me, so the further away from me it is. In the visible part of the electromagnetic spectrum, the longest wavelengths correspond to red light, which is where the name redshifted comes from. If I know the wavelength of the light that was originally emitted by a galaxy and I then measure the redshifted light, I can figure out exactly how fast the galaxy is moving away from me and hence its distance. If you'd like to know more about how astronomers measure distances in the universe, let us know in the comments and we'll do a whole video just on this. The JWST measurement showed us that our galaxy JADES has a redshift of Z higher than 14, making it the furthest galaxy ever detected. With ALMA, we were able to refine this measurement, gaining in accuracy by a factor of over 200, and we now know that the redshift of JADES is in fact 14.18. The new results we have for this galaxy tell us that the very early universe evolved much more rapidly than previously thought, which presents quite a challenge to our models. So astronomers are super excited. Many hours have gone into similar searches, but without these kind of results. So we're just waiting to look at more very young galaxies with ALMA to figure out how life, the universe, and everything came to be.